matter. We need to locate it immediately.
To you, antimatter might sound like science fiction, but what I want to get over to you in this talk is that antimatter is science fact.
All right, guys, today we're going to discuss some interesting facts about the 2009 film Angels and Demons, which is based on the novel by Dan Brown. The movie tells the story of a terrorist threat from a group called the Illuminati. Interestingly, in the film, there's an explosive device called antimatter that is stolen from a lab to blow up the Vatican. The cool thing is, this antimatter isn't fiction, and the lab isn't either. The lab in the film is CERN, a real-life laboratory located in Geneva, Switzerland. It's famous for having the world's most sophisticated, largest, and longest machine called the Large Hadron Collider. It's 27 kilometers long and runs underground, crossing the border between Switzerland and France. The machine's purpose is to accelerate particles to near the speed of light and then smash them into each other to break them into other particles. One of these broken down particles is antimatter. What you should know is that the Angels and Demons film actually collaborated with CERN to introduce antimatter, which was a real subject of research at the lab at the time. So everything said about antimatter in the film isn't a fantasy.
But if it were to fall out of suspension and come in contact with matter, say the bottom of the canister, then the two opposing forces would annihilate one another violently.
If I have 1/4 gram of normal matter meeting 1/4 gram of antimatter, then the resulting annihilation has the explosive force of 5 kilotons of TNT.
Equivalent to about 5 kilotons.
In this video, we'll discuss in detail what antimatter is. You have to watch this video until the end because antimatter is not an ordinary thing. You'll learn that antimatter actually reveals that the universe originated from nothingness.
You're talking about the moment of creation.
Yes.
But this is what nothingness looks like from the perspective of our current theories of physics.
In other words, we want to know exactly what it is about antimatter that made evolution of the universe happen.
The Illuminati were a secret society dedicated to scientific truth. The Catholic Church ordered a brutal massacre to silence them forever.
Okay, let's talk a little bit about the background of the Angels and Demons movie. This film is based on a novel by Dan Brown and is the second film adapted from his novels. The first film, which I'm sure many of you are familiar with, is The Da Vinci Code. The Da Vinci Code once caused a global stir and was even banned in many countries because it was considered misleading. This is because the film told a different story about the life of Jesus, which was depicted as being hidden in a Da Vinci painting. What made it controversial was that the author claimed that information in the film was accurate, making the Da Vinci Code one of the most controversial films in history. However, Angels and Demons wasn't as controversial as the Da Vinci Code because it was more of a science fiction film, even though it still raised religious issues. What makes this film interesting is the story of the Illuminati. Of course, many of you know about the Illuminati conspiracy theories outside of this film, but the Illuminati in the movie are said to be composed of scientists. They are in conflict with the church because at the time, much of scientific knowledge was considered to be in opposition to religion. In the film, it's even said that Galileo was a member of the Illuminati who was punished for saying that the Earth was not the center of the universe.
I said the earth was not the center of some universe with heaven above, hell below, as the church had said it was.
So they forced him to recant in the second book.
In Angels and Demons, the Illuminati group rises again to seek revenge on the Vatican. They kidnap 4 cardinals and plan to kill one every hour, with the climax at midnight when the Vatican will be blown up using antimatter stolen from CERN.
We will brand your perfidy deep and sacrifice them on the altars of science. Then bring your church down upon you.
Now pay attention, guys. There are 3 interesting facts in this film that connect to the real-life facts about antimatter. The title of the film is Angels and Demons. You may not realize that this title isn't just about the conflict between good and evil. Angels and Demons also symbolizes matter and antimatter. In physics, matter and antimatter are two opposing things. You'll understand this better after we discuss it in detail, but what's certain is that if matter and antimatter meet, they will annihilate each other. That's why in the movie, it's explained that the tube of stolen antimatter must be found before its battery runs out. This tube uses magnetic fields to keep the antimatter contained and prevent it from coming into contact with its surroundings. In Angels and Demons, it's said that Illuminati means the enlightened, which is related to light.
The Illuminati did not become violent until the 17th century. Their name means the enlightened ones.
This is why the Illuminati group uses antimatter to blow up the Vatican. The explosion isn't an ordinary one. It's an explosion of light. So by using antimatter, it's as if the Vatican is being swallowed by light, which symbolizes the Illuminati's victory.
Vatican City will be consumed by light.
The light in this scientific context is related to Einstein's formula, E is equal to mc squared. This c here means the speed of light, which we will discuss later. Angels and Demons essentially raises the issue of the conflict between science and religion. The Illuminati rise again in this film to seek revenge on the Vatican for the Church's mistreatment of scientists in the past. They plan to retaliate using the latest technology, antimatter, to make it seem as if science is superior to religion. But what's interesting is that the film suggests the discovery of antimatter could actually reconcile science and religion, because antimatter is said to reveal the process of how the universe came to be.
His Holiness thought that the discovery could actually scientifically prove the existence of a divine power, begin to bridge the gap between science and religion.
This is not far from the real facts, as one of the main reasons scientists research antimatter is to uncover the origins of the universe in the first moments of the Big Bang. To help you understand how all of this connects, let's now discuss in detail what antimatter is and its history. Alright guys, to know what antimatter is, you must first know what matter is. In physics, matter refers to everything that makes up the universe. In school, you learned about molecules and atoms. For example, water is composed of water molecules called H2O because its molecules are made of 2 hydrogen atoms and 1 oxygen atom. All other objects in the world are also made of atoms. That's why you were introduced to the periodic table to learn about the elements and their atoms. But even atoms themselves are made of smaller things called particles. Inside an atom, there are 3 types of particles: protons, neutrons, and electrons. The number and composition of these 3 particles differentiate one atom from another. But it doesn't stop there, guys. Scientists later discovered that protons and neutrons are actually made of even smaller particles called quarks. And if you go deeper into particle physics, you get even more confused because there are many types of particles with 17 different types discovered beyond the ones you already know. The point is, these particles are what are called matter in physics. They are the material that make up objects like bricks and cement in a building. So if these particles are matter, what is antimatter? Well, we have to discuss that at some length. The 20th century was a period of a great revolution in physics, where physics no longer talked about big things like a falling apple or a rocket, but about very small things, particles. Physics also stopped talking about things that moved slowly, but rather about things that moved very, very fast at the speed of light. At that time, 2 major theories were formulated that changed physics completely: quantum theory and Einstein's special theory of relativity. If you understand these 2 theories, you'll understand why physics could go into imaginative things, from interdimensional travel to time machines. So, what's the connection between these two theories and antimatter? Antimatter is the result of combining these two theories. Initially, the two theories were not related because they discussed two different things. Quantum theory talked about particles or objects that were very small, but it didn't talk about how fast those objects were moving. On the other hand, Einstein's theory of relativity talked about objects that were moving very fast, reaching the speed of light, but it didn't discuss their size. Over time, scientists realized that these two theories had to be combined. Why? First, particles are quantum objects with a very light mass. In fact, photons, which are light particles, have no mass at all. Because their mass is so light, these particles can move at the speed of light. And second, quantum theory couldn't explain why an electron can absorb energy in specific quantities and release it in specific quantities, allowing it to move between different orbits in an atom. The answer to this problem in quantum theory is in Einstein's E equals mc squared formula. This formula contains three letters representing three things: energy, mass, and light. In short, this formula states that mass, or matter, can be converted into energy, which is equal to the mass multiplied by the speed of light squared, and vice versa. Energy can be converted into mass, or matter. Therefore, this formula can explain the process of energy transfer between quantum objects. So, in 1928, these two theories were successfully combined by a physicist named Paul Dirac, who merged Einstein's E equals mc squared with Schrödinger's equation. In 1932, a physicist named Carl David Anderson was studying cosmic ray radiation in a device called a cloud chamber. He found something strange: the trail of a particle that was exactly the same as an electron, but with the opposite direction and a positive charge. He speculated that this was the anti-electron that Dirac had mentioned. At that moment, he named it the positron, a positive electron.
The red trail at the bottom is a positively charged electron, the exact mirror image of the regular negative electron. It's an example of antimatter.
You may not be aware that antimatter is already a technology used in hospitals in a machine called a PET scan, which is commonly used to detect cancer. PET stands for positron emission tomography because it uses positrons, the antimatter of electrons. Since the discovery of the anti-electron, scientists have been searching for other forms of antimatter because if there is an anti-electron, there must be an antiproton, an anti-neutron, anti-quarks, and even eventually anti-atoms. Some have even gone so far as to think that there might be a whole anti-world.
In principle, an anti-electron could form part of an anti-atom, and many anti-atoms could fit together to make an antimatter table, or even an anti-me.
You might be asking, what the importance of antimatter is to scientists. There's something you should know that might be a bit surprising. As we discussed, antimatter is the result of combining two theories, quantum theory and Einstein's special theory of relativity. The combination of these two theories actually resulted in a new one called quantum field theory. This theory is very abstract, very wild, and very crazy, because it concludes that the most basic element of the universe is not a particle, but something more abstract.
The best theories we have tell us that the fundamental building blocks of nature are not particles, but something much more nebulous and abstract. The fundamental building blocks of nature are fluid-like substances which are spread throughout the entire universe and ripple in strange and interesting ways.
It's complicated to explain, but the consequence is this. In a computer simulation of empty space, which was derived from this theory, scientists found that even in a vacuum, there is mysterious activity that scientists call quantum fluctuations. So what do these quantum fluctuations mean?
So even when there's nothing else there, the field is constantly bubbling and fluctuating. These are things that we call quantum vacuum fluctuations. But this is what nothingness looks like from the perspective of our current theories of physics.
They are the process of random creation and destruction of matter and antimatter. According to this theory, matter can appear from a vacuum, and its appearance is always accompanied by its partner, antimatter.
But when you bring relativity and quantum theory together, then you have, for certain, this notion of electron and anti-electron pairs just appearing out of the vacuum.
Scientists suspect that this is what happened during the Big Bang. Of course, science can't answer where the universe came from, but so far, they agree that the universe began from a quantum fluctuation, which means it came from a state of nothingness, followed by a tremendous explosion called the Big Bang. In the first moments of the universe's formation, the amount of matter and antimatter was equal. However, many of them then annihilated each other and turned into light, until finally a larger amount of matter was left than antimatter. The remaining matter then became stars and galaxies and planets and so on.
And what remains in the universe now is a consequence of a very tiny difference between the amount of matter and antimatter that existed at that point. But that difference is the reason why we're here. Because if we had the same amount of matter and antimatter, it would all have cancelled each other out, and the universe now would just be full of light.
That's why this giant machine was built by CERN. The machine is generally called a particle accelerator, but it is often nicknamed the Big Bang machine because it simulates the Big Bang. Scientists believe that all matter in the universe was formed during the Big Bang, so to understand the first moments of the Big Bang or to know the composition of the earliest matter, they have to reconstruct it using this machine. They do this by accelerating particles to a speed close to the speed of light, and then smashing them together at high speed. Scientists believe that the process of this collision is similar to the Big Bang. In this way, scientists have found other particles that were previously undetected, including antimatter particles. Unfortunately, antimatter has a very short lifespan, only a fraction of a second, because it disappears as soon as it comes into contact with other matter. That's why you see in Angels and Demons that antimatter is contained in a tube. This tube uses a magnetic field to prevent the antimatter from coming into contact with matter. And this is a fact about what CERN does as well.
So Alpha is in the business of making antimatter and studying it, making very precise measurements on the atoms of antihydrogen, which we can create here at CERN and trap in our Alpha devices.
Now, the question is, can antimatter be used as a bomb, as shown in Angels and Demons? Theoretically, yes, because it aligns with Einstein's formula E equals mc squared. The c here is the speed of light, which is incredibly fast at about 300,000 kilometers per second, and it has to be squared. According to this formula, if we have 1 gram of antimatter and 1 gram of matter, and they meet, they would have an incredibly destructive power.
If I have 1/4 gram of normal matter meeting 1/4 gram of antimatter, then the resulting annihilation has the explosive force of 5 kilotons of TNT.
However, that's almost impossible to achieve, because creating antimatter is extremely difficult. According to CERN, they can only create 1/1,000,000th of a gram of antimatter in 1 year. This means it would take 1 billion years to get just 1 gram of antimatter. So, that's it about antimatter. Actually, there's still a lot more to uncover about it, but at least you now have a basic understanding of what it is.